And also, I want to remind you that next week we will be on campus in room MS 413, and you will take your first exam at that point in that room. And I know we're first day back, we're going to take an exam, but you guys are more than capable of doing that. And then, we'll have every Thursday we'll be in that room unless something weird happens. And my office hours will be on campus. My office is MS 415K. There's a whole office suite. It's pretty obvious where you'll see my office. I'm second one from the corner. So I want to go through these. I will post this video. I'm going to close Zoom when class is over. I'm going to open it right back up just so I get roll. So because you guys get a point for being here for the Zoom session. All right. And also remember, I posted the answer key to the exam will cover homeworks 1 through 3. I posted the answer keys for all of them. Homework 3 is actually due the day of the exam. That's why I posted it early. So you can see, you can work on it and then check yourself. You may as well fix the answers before you put them in though, just so you can get the credit. But work through them and then check yourself. All right. And then of course I have office hours. All right. So let me go to screen share and I'm just going to walk through these. Oops. What am I sharing? Am I sharing the whole screen? Hang on a minute. Yeah. All right, there we go. You guys can see the whole screen, yeah? I don't see the little green line. You can see the whole screen?
Yes.
We see a whiteboard. Yeah.
Or do you see the questions over here?
Yeah.
Make sure, because usually there's a green line around it, but I don't see. Maybe it's because it's the whole screen. All right, so the first one, what is the density of salt water if 26.2851 grams occupies 23 mils? This one's pretty straightforward. D equals M over V. And in this case, they don't get much easier than this one. We'll start off with an easy problem. 26.2851 grams over 23.6 milliliters. You definitely, someone asked me about sig figs for the rest of your life. You should always express answers to the correct number of significant figures. All right, 26.2851 divided by 23.6 is 1.11. This will have 3 significant figures. So 1.11 grams per mil. All right, let's move this down here. All right, number 2 says, what is the mass? I'm not going to rewrite the question. So we want to find the mass. And so if you look at the question, we have liters, we have grams, we have milliliters. So we want to get a unit of mass. So mass is going to be in grams. So any unit of mass would be fine, but since we have one in the problem, let's do that. 13.6 grams per mil. That tells us that the 13.6 has to be on the top. So now we need milliliters to cancel. So we're going to need milliliters here, but we don't have milliliters, we have liters. So that means we're going to have to do a unit conversion, liters to milliliters. We want liters down here. And we know that 1 milliliter, milli means 10 to the minus 3. So that means liters will cancel, milliliters will cancel. And so you always want, even if you're doing it algebraically, you want to look for those unit conversions. So this will have, so the unit conversion, by the way, this right here does not affect your sig figs. This is going to have 3 sig figs. So this is going to be 21,100 grams. Or if you want to put it in scientific notation, you could be 2.11 times 10 to the 5th. Either way, someone asked, do you have to put it in scientific notation? You don't have to. I usually switch over when I get about 10 to the 3rd, 10 to the, when I start getting too many zeros. All right, number 3.
I have a question.
Yeah.
Isn't it 211,000?
Yeah, let's try it again. 18.55 divided by did I drop a 0? You're right. I dropped, see, that's why I put it in scientific notation.
Because I got the same answer. Scientific
Yeah,
notation.
thank you. Yeah, that's a good example of why I always switch when I get about that far. You see how I dropped to 0? I did that on purpose to see if you guys would notice that. All right, number 3 says, what's the volume? So again, anytime you have two numbers, it's not necessarily obvious where you're going to start the problem. That's why I always say, even if you're a really good problem solver, never a bad idea to write down the units of the answer right away so that you solve the right problem. So I have milligrams, I have grams, I have cubic centimeters. Cubic centimeters are a unit of volume. So a distance cubed is a volume. So it's good to know that that's a unit of volume. So I can go, I didn't say how many liters, I said what's the volume. So any volume unit is fine. So that means I need cubic centimeters in the bottom. The cubic centimeters in the bottom, I'm sorry, I need cubic centimeters in the top. That means the 7.13 grams is going to go in the bottom. So now I need grams, but I have milligrams. And also, does my answer make sense thing is not a bad idea, right? Liters, 15 liters is a lot. Liters is like a quart. So this should be heavy, right? And then this is milligrams. So this should be a very small volume. So that means I need grams on the top. I need milligrams on the bottom. And again, I'm using milli a couple of times, but it's 10 to the minus 3 grams is a milligram. Make sure your units work. And so 25.55 times 10 to the minus 3 divided by 7.13. I'm going to put this in scientific notation because it hurts my eyes. All right. So this one also has 3 sig figs. This is going to be 3.58 times 10 to the minus 3rd. And again, you don't have to put it in scientific notation, but it does help. All right. Number 4. Number 4, I wrote the word pi in here only because when I convert this to PDF, sometimes it doesn't like the symbol. So number 4, I'm going to make this, clean it up a little bit. So we have a radius is 22 millimeters. We have a mass of 175. Just going to write it here so I don't have to go back and forth. 46 grams. We want to know the height, question mark. And we're given that the volume of a cylinder is pi r squared h. And we want to know the height, and we're told that the density also is 7.13 grams per cubic centimeter. All right, so this is a little bit of a mess. And by the way, as far as pi goes, I gave you the value, but most scientific calculators have a pi key. So just push the button, right? If you don't remember what the value is and you don't have a pi key, I told a couple people, you can ask me questions. You can come up to the desk and ask me a question during the test, and I'll answer what I can answer. All right, so don't be afraid. If you don't understand a question, you don't know what you're being asked, come up and ask me, I'll help you out. All right, so I've got 1, 2, 3 different numbers and an equation here. I don't know where to start. So let's start with the answer. V is pi r squared h. So that means I can rearrange this. I'm just going to do the rearrangement in one step. But if some of you, need a little help with the algebra, I can slow it down, like come by an office hour. All right, so I'm just going to divide each side by pi r squared. That should be h. All right, so that's all we need. We just need, so all we need, we have r, we just need v. All right, now we have r is in millimeters, by the way. So we could even kind of put that in. So how are we going to get v? I'm going to go up here, work on this one, erase just this part. All right, so I'm kind of wrapping this back around. So I need to get v. So how can I get V? Well, I have a unit of volume right here, right? cm cubed. So to get cm cubed, that's a unit of volume. So I can do this. I can get cubic centimeters. And so what I'm looking at the wrong problem. So I have 1 cubic centimeter over 7.13 grams. And I have 175 grams. That's easy. I don't have to do a unit conversion here. So now my units cancel. So I can get the volume. All right, so that's going to be 24.6 cubic centimeters. And that equals V. So I'm going to erase this now to finish this problem. So if I plug that in, and I have, whoops, I don't want to do that. So I'm going to plug that into here. H equals V. I'm sorry. Oh, that's right. I'm sorry. It's right here. Just moving it up here over pi r squared. So this is 24.6 cubic centimeters over pi times 22 millimeters. All right. And so I'm going to have, and that's squared. So I'm going to have a problem here. I'm going to have to do a unit conversion, but let's get this cleared up first. Let's do the math here. So 24.6 divided by 22 squared divided by pi. So this looks really weird at first. This is 0.0162 centimeters cubed. I said cubed and I wrote squared per millimeter squared. So these units don't cancel. What I would like, since I have the higher number is the cube, I would like to get this into centimeters. Move this over just a little bit. So to do that, what I would like is a unit that has millimeters squared in the top and centimeters squared in the bottom. All right. And so then I can do this. So this is a little bit tricky. If I want to go from millimeters squared, let's do this. Well, it doesn't matter. Millimeters squared to centimeters squared. I need that relationship. I know that 1 centimeter is 10 to the minus 2 meters. And I know that means let's put centimeters squared here and millimeters squared here, because I need to figure out this conversion factor. So I'm going to get how many millimeters squared in a cubic centimeter. And I know that, so I want to get centimeters squared to make that unit work. 1 centimeter squared is 10 to the minus 2 meters squared. So 1 centimeter squared is 10 to the minus 4th meters squared. All right, so I've got this unit because I'm trying to get this. So now I need to get, I'm going to move this over. It's a little bit messy. I apologize for that. So what I need now is meters squared here and millimeters squared here. So the same idea, 1 millimeter is 10 to the minus 3rd meters. So then 1 millimeter squared is 10 to the minus 3rd meters squared. So 1 millimeter squared is 10 to the minus 6 meters squared. And so then I can do the math. 1E4. I get 100 here. So that means there's 100. Did I do that wrong? That's right. I'm sorry, I pushed my buttons wrong. It's 0.01. I set it up right, I just pushed the buttons wrong. My bad. So that means 1 millimeter squared is 0.01 centimeters squared. So that means this is going to be 1.62. So let me go through that little mess again. All right, that's why I wanted to have a little extra time here. So I get to here, but you see I have centimeters cubed and millimeters squared. Now there's a couple of little shortcuts. If you look at this, and you see this cancels, and I get centimeters. If you look at this and you go, oh wait, right away, if you realize ahead of time just to convert the 22 millimeters into centimeters before you square it, that would make this problem easier. But I'm going with if you didn't remember that, didn't realize that. So when I get to here, I need to get a unit of distance, which is linear. So there's no squares. And since I have a cube and a square, I'm going to go for the one that was cubed and make it into linear. So I need centimeters squared here, millimeters squared there. And so to find that out, I had to go through this. So this is like we were doing with cubics, but it's only squares. So I need centimeters squared. I can relate it to meters because you can always relate the 2-letter one to the 1-letter one. And so I squared it. That's where I got to 10 to the minus 4th. Then I had to do the same thing with millimeters squared. So I said a millimeter is 10 to the minus 3rd. So then I squared it. That's how I got 10 to the minus 6th. And so then I do the math and I get 1 millimeter squared is 0.01 centimeters squared. And then I did the rest of the math. So there are a couple, that's probably that's if you know only what I taught you. All right, if you happen to know a couple other things, there's some little bit easier steps, but that would require you to remember some things that I didn't tell you to remember.
I have a question.
Yeah.
So I converted millimeters to centimeters right away.
So then you would have 2.20 centimeters here.
Exactly.
Yeah, then you would skip this whole step.
So I squared that, right? Yeah. Because I mean, because it's pi r squared, right? So I think I got like 50. What did I get? I think I got 15.2. I don't know if that's right. Actually, it doesn't sound right. Did I cube it? Maybe I cubed. Oh god, what did I do? Oh yeah. Okay. So
you just did a button pushing wrong. I got 1.62 when I did it your way. I got the same answer.
Yeah, I guess what I got confused is eventually I got to the point where I had 24.6 grams over centimeters cubed, like over 59.3 centimeters cubed, and I don't know how to.
Okay, well, if you did this and then you square this, right? What you did is, so what he is talking about is if you realize, oh wow, these units aren't going to agree, before you start doing the problem, you go, I'm just going to convert this to centimeters right away, and then you square it, you would have 2.2 centimeters, and then you would square that. And then, so then it would look like this, 2.2. So it would look like this. So if you just change this to 2.20 centimeters squared, you'd still get the same answer. You just wouldn't have to do this here.
Do you mind quickly showing us that? Because that times pi gives me 15.2 centimeters squared, right? So
That's exactly what I got. Was 15.2.
On the bottom.
But yeah,
Yeah.
well, that's not the final
Okay,
answer.
so if you do this, you go 24.6 centimeters cubed over pi times 2.20 centimeters squared. All right, then you go, so then you get 24, I'll just do every step.
If you don't mind, just very briefly, and then if I've still a
Pi
question.
times 4.84 centimeters squared. Over 15.2. You get the final answer is 1.62.
So how do
That's
you do
exactly
that?
where I got stuck.
Same here.
Well, I don't know. It's a button pushing thing.
Well, now, yeah,
So
I mean-
2.2 squared is 4.84. 4.84 times pi is 15.2, and then you have to divide 24.6 by 15.2.
yeah, but that's centimeters cubed over centimeters squared.
That gives you centimeters.
Oh, okay, they just cancel, it's just like X. Cool. All right, that's easy then. Thank you.
That
All right.
completely answers my question as well. Thank you.
Okay, good. I want to go to the specific heat questions. That one's challenging. There are two ways about it. Okay, specific heat questions. Let's do those. Okay, so the first one's pretty straightforward. Number one on the specific heat questions, we have 2750 grams at 4 degrees. This is water. And TI is 4. TF is 85. So Q is MS TF minus TI, since we have two temperatures. So this is pretty straightforward. Just watch your sig figs, 85.0 minus 4.0. Those zeros are significant. So this becomes 81.0. So that's 3 sig figs. So I have 3, 4, 3. So 2750 times 4.184 times 81. And let's put this in scientific notation. So I get 9.32 times 10 to the 5th joules. A joule is very small, so it seems like a big number, but that's because it is. Joules are very small. All right, number 2 is you're told 9840 grams. You're told 31850 joules. It's the same specific heat because it's water and you were given that. TF is 85. TI is your question mark. That's an I. So you can rearrange the equation first if you want. So that means Q, I'm going to divide each side by MS. Q over MS will be TF minus TI. So if we go Q over MS minus TF will be negative TI. So that means TI will be TF minus Q over MS. Just flipping that over to get rid of the negative sign. And then it's going to be TF is 85 minus Q is joules. Whoops. Over the M was 9840 grams. Okay, I'm going to move it up here to finish it. We'll do 3 and 4. All right. All right, so then it's 85. You got to watch sig figs here. When I do the math down here, 31850 divided by 9840 divided by 4.184. All right, so I'm going to drop to 3 sig figs. I get 0.774. And that's going to be, if you look at the unit, degrees C. So when I do this subtraction, let's do it over here, 85.0 minus 0.774. I'm going to make sure I didn't push a button wrong, just real quick. Divided by 9840. That's, whoa, try that one more time. Oh, that's right. All right, so I'm gonna, my guess is only gonna go to the 1 to the 10th place. All right. So it started at 84.2. But just watching the sig figs there. All right, number 3. All right, number 3, we've done stuff like this. We've done a couple of these in class, and this is like the last one on that last homework as well. Space. So number 3, we have copper, and we have 950 grams. We have S equals 0.38 joules per gram degrees C. We have TI. This is S. This is M. TI is 195. Okay, we have water. I'm going to use W for water. We have 2250 grams. It's S, water, is 4.184. And TI of the water is 5. Sorry for the handwriting. TF equals question mark. I'm going to move you guys up here now. Okay, so this is like a couple that we've done. Okay, so we have Q copper plus Q water equals 0. So then we have the mass of the copper, specific heat of the copper, TF minus TI of the copper, plus mass of the water, equals 0. Plugging the numbers in, the mass of the copper
Wait, how do we know that equals 0? Oh, I'm not
because the
exactly.
sum of the heat, that's the law of conservation of energy. The sum
Oh,
of the
right.
changes equals 0.
Okay, okay.
Mhm. Mass of the water. What a mess. All right. So just like we did before, I'm going to multiply the 950 times the 0.385. All right, so I get 3 sig figs when I do this. So I'm going to just round it, 365.8, but keeping an extra digit, joules per degree C, TF, let's put that in parentheses just so we don't get confused. Plus 2250 times 4.184. And that's going to drop to 3 sig figs as well because of the 2250. So I get 9414. Again, I do this, whoops, what is that? That's going to be joules per gram times TF minus 5 equals 0. Now distributing through 365.8 joules per degree C times TF minus the 365 times 195. It's going to be a big number. All right, so that's going to be, and that's 3 sig figs, 713. I'll put it there, and that's in joules. So I multiplied the 365 times the 195, then 94 joules per gram times, that's joules per degree C, Ron. I don't know what I'm doing. Here, this is how you confuse your students. There you go. And that's going to be times TF. And when I multiply that times 5, I'm going to drop to 2 sig figs. So 47 equals 0. So now I got to move this up. Move this over. Move you guys. There we go. So going up here now. Okay, so I'm going to combine the TF terms. So the 33, and this has the sig figs on. So the 9414 and the 365, the guess is in the tens place. So the things I'm under the TF terms, I'm going to combine. Okay, 365.8 plus 9414. So that's 9. And the guess is in the tens place. So I'm going to go 9780 joules per degree C. That's my guess. Times TF. Then when I take the double underlines here, this guess is in the 10,000, the 10,000s place, and the guess is in the hundreds place. So 47. So I get 118330. I'll just drop the 330, and the guess is the 8. All right, so I'm going to erase this stuff. Basically done now. 9780 joules per degree C times TF equals 118000 joules. And the 8 is the guess here. The 8 is the guess here. That means I have 3 sig figs. And I get 12.1 degrees C. All right, so we've done several problems like that. So just quickly, because I only have about 6 minutes and I got one more problem to do, but that one's a little bit easier. All right, start with this. Anytime you have 2 substances, the conservation of energy, expanded out the equation, plugged in the numbers. At this point, right up to here, when you got all the numbers plugged in correctly, that's 8 out of 10. Then it's math. So you're just watching the sig figs. When I do this math, this has 3 sig figs. So I keep an extra digit. If it bothers you, if you're really confused, you just round at each step because your answer won't be very different. Same here. Then I distribute through the parentheses. Then I combine like terms. And when I do the addition, that's where I got to really watch the sig fig. So this is the ones place, but this is the tens place. So it's the tens place. This is the hundreds place. This is the thousands place, excuse me. No, 10,000, whatever. It's that place right there, right? Fourth decimal place. So I have 3 sig figs when I do that. All right, because I have 5 minutes. It's the last one. It's similar, but the math is easier on this one because of the way it drops out. All right, number 4, we have aluminum, and it's S is we have TI for the aluminum is 225. Well, for the water, we have mass of water. We have 1725 grams. All right, we have TI of the water is 12 degrees C. We have, of course, the specific heat of water. And then we're told the final temperature, TF, for everything is 17.5. So we're trying to find the mass of the aluminum. Right? It says, what is the mass of the aluminum? So it starts the same way. Q of the aluminum plus Q of the water equals 0. Then it's mass of the aluminum, specific heat of the aluminum, TF minus TI of the aluminum, mass of the water, specific heat of the water, TF minus TI of the water equals 0. So we start plugging things in. We don't have the mass of the aluminum, but we do have this 0.900 joules per gram degree C. We have TF and TI, 17.5 degrees C minus 225. Mass of the water is 1725. And then we have TF 17.5 and TI of the water was 12. Yeah. Equals 0. And so this is just a number here. And by the way, but when you do this, this is 5.5. See that? I had to kind of skip a step here. So then I have mass of the aluminum times 0.9. I'll just put this step in. 17.5 minus 225. This is negative 207. Plus, I'm going to do all the math here and realize it goes to 2 sig figs. So 1725 times 4.184 times 5.5. So this is 30. This is really 39,700. But it has 2 sig figs equals 0. I'm going to just do this math now. Mass of the aluminum times, this is going to drop to 3 sig figs, 0.9 times 207.5 is negative 1.8. And this is going to be joules per gram plus 39,700 joules equals 0. And then finishing it off. Okay, I have mass of the aluminum times negative 186.8 joules per gram equals negative 39,700 joules, just moving it over. And then the mass of the aluminum would be 213. And I'm sorry to keep you a minute late. Okay, so those of you have, I know some of you have to go. I apologize for running just a minute over, but I wanted to get this done. I will post the recording. All right, I'm going to stop the share. Well, I'll leave it open. So those of you, if you got to go, you got to go. I want to close this before my office hour, but I'll keep it open for a minute or two to answer any questions about this. But I do want to turn off the recording. Let me do that real quick. I'll turn the screen share right back on.